Hey guys, so welcome back. Today we have another video on singly linked lists, but this time we're going to be looking at the delete function, and it's pretty self-explanatory. All we're going to do is we're going to delete a node from our singly linked list, and so this is a quick example. If we have a list here with A, B, C, D, and none at the very end, right? Because the very last node points to none, and we want to delete C. Delete the node that holds the data value of C. We want our node to look like this, where it's A, B, D, and then that D points to none. And so, I mean, that's pretty self-explanatory. If you want to try it on your own, definitely pause the video and go and try it because that's the way you're going to learn the best. But if you ever have trouble or you need some help, definitely come back and we'll work on it together. And so hopefully you've done that by now. I have the code here. What I'm gonna do is I'm just gonna go through the code a little, talk about the different situations you're gonna handle for, and then I'll remove all this and we'll code it together. And so when we start off, we want to make sure the list isn't empty, right? Because you can't delete from an empty list. So all we're gonna say is this is gonna be handling for the empty list. If there's not a self.head, we're just gonna print list is empty, and then we're just going to return because we know right there that uh, we can't uh, we can't delete from an empty list. If the list is not empty, what we're going to say is we're going to set a cur variable equal to self.head and a previous variable equal to none, and we're going to loop through. And what we're going to do is while there's a cur node, we're going to say that if the current data is equal to the data that we want to delete, that we pass that as a parameter, we're going to look at two cases, right? One case is the data could be the head node, right? The data, say we have A, B, C, D, or A, B, C. If we want to delete the A, then there's no previous, right? So we want to reset what the head node of this list is to be, and we want to handle for that separately. Or our second case can be that it's not the head node, and it's a node that's after the head, and so that's kind of its own separate case. And so this is just a brief look. If uh, this is the current node we want to delete, this case is for if the node is the head node, and this little chunk of code is for if the node is not the head, but it's sort of in the middle of the list. And if the current node is not a node we want to delete, is not a node that we want to delete, we're just going to loop through and we're going to keep looping through until we get to the end of the list. And so I know that may not have made as much sense, but we'll go through it right now. And so what I'm going to do, I'm just going to delete all the code. I'm going to leave all the comments there because we can kind of look at that as a little guidance. And perfect. So I'll remove this. I'll move these over. And okay. So in our delete function, the first thing we want to do, we want to handle for, before I continue, let me show you, I just made a quick list. I just made a list. And so this is, SLL singly, this is, we looked at the pen function in a previous video. This is the list that we're going to be starting off with, and we'll use the delete function to kind of play around with this and make sure that our delete function actually does work. And so I just want to make sure I say that so I don't forget about it. So first, what we're going to do, we're going to handle for if the list is empty. If the list is empty, that means we know there's not a self.head, and so the self.head a parameter for the class is going to be 0, or is going to be equal to none. And so all we're going to say is if not self.head, we are just going to return, right? We'll even print, I think what I said before, we'll print list is empty. right? If there's not a self.head, we know the list is empty, and so we literally just print it out and we return. So that's where the list is empty, right? What we want to handle for is now if the list is not empty. And so what we want to do in that case is if the list is not empty and we get, say we want to delete, in this case, we want to delete the C node. What we want to keep track of is keep track of what the previous node is and what the current node is. So if we land on a current node that we want to delete, we want to reroute this arrow so that this node is not pointing to this C, but is actually pointing to the D. And we're gonna do that in the code. And obviously we're gonna handle for if the node to delete is in the self.head. But in order to do that, we're gonna say prev is equal to none, and the cur node or cur is equal to self.head. And so this initializes our variables. The cur is a self.head. The previous node is going to keep track of what the previous node is, or the node before the cur node. And then what we're going to say is while cur. So we're going to loop through the whole list while cur. If cur.data is equal to data, the data that we passed here, we know there's going to be two cases here, like we were saying before. So let me move this up. So these are the two cases. If the current node that we want to delete is the head node, then we want to handle for that differently because there's no previous node, right? We just have to reroute what the self.head is. And if the node is in the middle, then we're going to have to reroute some of the arrows. So first what we're going to do, we're going to check if the current node, or the node that we have to delete is the head node. So we're going to say if cur is equal to self.head, right? We're just going to say that self.head is equal to self.head.next. And then what we're going to say is that that is all we have to say. Then that's all we have to say, right? And so what we're saying right here is we're just saying we're resetting where the self.head is. Instead of, say we want to delete A, instead of making the self.head at A, we're just going to say the self.head is at the B node. And that's all we're going to have to do for that. Now, if else, so if we do else, we know that our node is sort of in the middle. And so what we're going to say here is we're going to make a next variable, call it, and we're going to make that equal to cur.next. So in this case, if I replace this with the C, if our cur node is a C node, we want to delete this node, right? And so what we're saying is our prev node is going to be the B. We want to keep track of what our next node is, or what our new next node should be. And so we want to make sure that our previous node is pointing to that next node. And so that's what this next node is. This next node in this case is going to be the D. Sorry about that. It's going to be the D. And we're going to say that prev.next is equal to next, right? And then what we're going to say, we're just simply going to delete cur. And we're going to say cur is equal to next. And so what we did over here is, remember, if we want to delete this C, if we take this out of the equation, our prev node is still going to be this B, right? But we just replace what our current node is with that next variable that we stored. And so by doing that, we got rid of this. We set our next node. We rerouted this so that we got rid of this, and our B node is pointing to the D, and we're saying the prev is still the B, and our new cur is going to be equal to that next value. And so by doing that, we completely erase that C, and we move on to our next node, which is this D. And so our last case is So this case was if cur.data is equal to data. If our cur.data is not equal to data, we are just going to say prev is equal to cur, and cur is equal to cur.next. So what we're doing here is we're just saying that our prev is going to be equal to the current node that we're on, and then we're going to move our current node and move it to the next node. So basically, if we were on B, since B is not the node to delete, if we were on B and our current node was B and our previous node was A, we're saying that our previous node is now going to be equal to B, and our current node is going to be equal to the node after B, which is C. So our new prev node would be B, and our new cur node would be C. And so we're just going to loop through it. And so what this is going to do, this is going to loop through everything. If we ever get to a case where our current node is the data that we want to delete, then we're going to delete it. If not, we're just going to loop through. And so this is good for handling, this is good for removing every single node every single instance of the node that holds that data, if you will. And so what that means is if this was my list and I wanted to delete C, by looping through every single node, we would get rid of this C over here, and we would get rid of this C over here, instead of just removing the first one. And so let's just look through this code to make sure this would probably work. If we don't have a self.head, we're just going to print the list as empty, return. If the list is not empty, we're going to say prev is equal to none, cur is equal to self.head. If our current data is the data we want to delete, and it's the self.head, we're just going to say self.head is equal to self.head.next. If it's not the head, we're going to say our next is equal to the current.next. Our previous node should point to that new next node. Delete the current node and state that the cur is equal to the next node. And if not, we're just going to keep looping through. And so I think that should do. I'm just making sure I'm not forgetting anything here. If cur is equal to self.head, self.head is going to be equal to self.head.next. That looks right. I don't think we're forgetting anything. They're not missing any return statements, I don't think. And so this is what our original list looked like if we remove the C. Oh yeah, so we removed the C node in our list. And so what happened here was this was a case where we looped through everything. We got to a point where the current node that we want to delete was the data element of that node was equal to the data parameter that we passed. And since it wasn't the head node, we said that we went through this small piece of code. And so we said that this D was that next node that then was equal to that next variable we set. The B was the previous node, and so we said the previous.next was equal to that next variable that we stored. And we just deleted the C, and we said our cur node was equal to the next node that we stored earlier, which remember we said was the D. And so by doing that, we got rid of the C node, and when we printed it out, since the C wasn't there anymore, we never printed it. And so that is that. And let's try a couple different ones. We can try removing the head node to make sure that works. Okay, so that did not work. If cur is equal to self.head, cur is equal to self.head, self.head is equal to self.head.next. Yes, so this is the one line of code I was forgetting. What you want to do is if your self.head, we reset where our self.head value was, right? And so the problem is that once we do that, we never reset what our cur node was. Because over here, even though this says self.head, this is like saying, so we had A, B, C, D, right? Our cur node was A. And so over here, our cur was equal to the A. And so since we want to delete the A, what happened here was that our cur was equal to self.head. We moved our self.head over, but we didn't have this line of code. And so we looped through everything. And when we got to the cur, since this cur existed, we looped through, but this this cur didn't have a next value, right? And so that's why it said none-type object has no value next, and the prev.next equal next doesn't work, because when we loop through, we wait, prev.next is equal to next. Yeah, so what happened was, oh yeah, sorry. So what happened was we reset our self.head, and when we looped through everything, our current node was still equal to the A. And so what happened was the A was the node was a node we want to delete, but it's not the self.head anymore, right? Because we reset what the self.head was. That means it went through this loop. But the problem is our prev was equal to none. And so that's why it says here our none type object doesn't have an attribute next, because our none is none. It doesn't have a next attribute. And so that was giving us errors. And so what we need to do, we need to reset what our current head is. So we need to reset that our cur is equal to self.head, because what this did is instead of storing it as A, it stored it as B. And so now when we looped back through, our cur was equal to B, and we looped through, and then we were able to have a previous, and our previous was, we were able to set our previous equal to cur. And so basically what happened was, since we didn't reset our our cur node, our previous node was not reset as well. And so when we got to this line of code, it tried to ask for the next attribute of the none of the previous node, which was none. And so that was throwing an error. And so sorry about that, but hopefully that made sense. And so by resetting the current node, we're just able to loop through and move forward in the list. And so that was able to delete the BCD. And so if we try to, what I want to do here is, when you write your, the thing with this type of function is when you write this function, it's going to remove all instances of the data parameter that we sent. And so if we want to delete A, and we have multiple instances of the A, it should delete both of them. So if we have any luck and we try to run that, it does. And so just to prove that there were two, if we run this again, there are two A's over here, right? And then if I uncomment our delete method and I run this, both of the A's are gone. And so the reason this happens is because we don't just stop after the first node, we're looping through to the end of the list. And so we're constantly looking for if the current node is the node you want to delete. And so if that happens, then we just keep deleting over and over until we get to the end of the list. And so all instances of the data all instances of nodes that have the data element that we passed are deleted. And so I'll just try one more time. Instead of B, I'll choose to add a C there and a C there. And so what that will do, now we have three C's on the second node, the fourth node, and the sixth node. And if I uncomment the delete method and I pass the C parameter, we get rid of all the nodes that held the data value of C. And so yeah, that's basically that. Hopefully that made sense. If you guys have any questions, make sure to leave them in the comments. Sorry about this little self.head thing. I hope it made sense. Definitely, if you have any questions, leave them in the comments, because I know that might have been a little confusing. But other than that, stay tuned for the next videos, and hopefully you guys learn something from this. All right, have a great day.